I gotta remember to edit this out. All right, so for problem number 15, I have this isosceles triangle, and there's some stuff given to us. What they've given us is that BA, line segment BA is congruent to line segment BC. They also give us that BD bisects angle ABC, and then we're asked, and I'll write this in blue, we're asked to prove that BD is perpendicular to AC, and that BD bisects AC. Okay, and so the first one I want to tackle is proving that it's a 90-degree angle. Okay, so now let me go through what's given and let's label that. First of all, it says that BA and BC are congruent. Those are labeled by these hash marks. And then the other thing is that BD bisects ABC. So this angle and this angle are congruent. That's what they're saying. All right. Well, I could prove that these triangles are congruent, and then once I prove that the triangles are congruent, then I could prove a bunch of other stuff. Okay? So the first thing, and then we're told that so let's I'm not going to do like a formal proof. Well, maybe I might. I don't know. Let me think it through. But first thing I want to do is well, yeah, let's do a formal one because you guys, that's important to know. So I have a statement. Now I don't have any notes. I'm going to pretend to be a student, and I might make a mistake. So I hope you're writing in pencil. But I think what I want to do is I'm going to list the given, and I think the route that I need to take is simply that I need to prove that the two triangles, because if you look on the board, it looks like there's two congruent triangles, and I think if I prove that the triangles are congruent, then I can certainly prove that the angles are congruent, or that I can prove my proofs, that the one line bisects the other line, and then it does so in such a way that it's a 90-degree angle. And so let's get started with that. So I think the first thing I need to list is that my givens. So I'm given that BD is congruent to BC. Okay? And then I'm also given that BD bisects angle ABC. And that's all given. So that's really two things. Okay? And then I think the next thing that I want to do is I want to point out what I wrote down. If it bisects, then I know that angle ABD is congruent to the angle CBD, right? And that's just based on the definition of congruence, or definition of a bisector is a better way to write it, right? When we bisect an angle, then it splits the angle into two congruent parts. So I say definition of a bisector of an angle, but I'll just say definition of a bisector. All right, cool. And so now, now we got to prove the congruent triangles. So another thing I'd notice is that BD is shared by both triangles. So I suppose I could say that BD is congruent to BD. Whoops, that should be a straight line. And that's the reflexive property, right? All right, so now what do I have? I have an angle, and now I have a side. So I have an angle side theorem. So I'm going to say, this is not the proof, but I'm going to say that triangle ABD is congruent to triangle CBD based on angle side postulate or theorem. All right, cool.
You mean
Oh no, side angle side. Why did I write angle here? I'm a goofball. So I have a side, and I have an angle, and then I have a side. So this is really technically side angle side. So now if that's the case, now I can list a bunch of stuff. So I can list, I've proven that BD bisects AC, right? So what I could say is I could say that AD, line segment AD, not B, that's D, is congruent to line segment CD. Corresponding parts of congruent triangles are congruent, right? So now I've proven this. 1, 2, 3, 1, 2, 3. Okay, cool. Now, what that lets me say is, that allows me to say that BD bisects line segment BD bisects AC because it splits AC into two congruent parts, right? And so that's good. And so that would just be a definition of a bisector. So that's a bisector of line segments. So I could check this off the list, right? I've done this. Now I just have to prove BD is perpendicular to AC. Well, I certainly know, I know this for a fact, that angle ADC is congruent to angle CD, oh, it's ADB, I'm sorry, ADB, let me erase it real quick. Angle ADB is congruent to angle CDB, right? Again, that's congruent parts of, or I'm sorry, corresponding parts of congruent triangles are congruent, CPCTC, all right? So what did I just prove? I just proved that this angle is congruent to this angle. All right, cool. So now I know that they're equal to one another. And then by, when I look at that, I also know that angle AB, or ADB, and angle CDB are a linear pair. Why? Because they're on the line AC. And what we know about the linear pairs is that angle ADB plus angle CDB have to add up to 180 because linear pairs are supplementary. Okay? Well, since they equal the same thing, I could say that ADB plus CDB is the same as saying ADB plus ADB is equal to 180. Okay? And that's, what do we call that? When we substitute something in, we call that the transitive property. This is a long proof. All right. So then really what I have is I have 2 times the angle ADB equals, ADB is equal to 180, right? If I divide both sides by 2, I get ADB is equal to 90 degrees. And so here I'm doing the multiplicative and the division properties all in one step, kind of solving it. And then I get ADB is equal to 90 degrees. Well, that means that because they're congruent, then ACDB is also equal to 90 degrees. Technically, we could say that's a transitive property. There's lots of ways. I've kind of gone off the script. The book says it differently, but I like to add the extra steps so you can kind of follow the logic. And so what did I prove? Well, because both those angles are 90 degrees, then I've proven that BD is perpendicular to the line segment AC. And now your book did kind of a short route. There really isn't a definition for that other than it's perpendicular, right? Perpendicular means that BD intersects AC at a 90-degree angle, which is true. I really didn't need to prove both of them equal 90, although I could have. Just with this alone, I could say that BD is perpendicular to AC. So what I did is I basically went through here and mathematically shown that this angle and this angle both equal 90 degrees. And if they equal 90 degrees, then BD is perpendicular to AC. And there's really no definition or reason other than the definition of perpendicular lines. So I guess I could say, by definition, of perpendicular lines. Okay? So that's problem number 15.